In this video, we're going to determine whether a quadratic function will have a minimum or a maximum point. So every parabola or quadratic function has a minimum or a maximum point occurring at its vertex. And the easiest way to see this is by simply looking at the graph. Now remember, a maximum point is a high point. And this is a very clear high point that we can get a coordinate for. So it's got to be a very clear point. A minimum point is going to be a very, very clear lowest point. Like this is the lowest point we get to on the graph. We can clearly see and define it. And then we go back up for all other points. So that's what we're looking for, is that we have a clearly defined maximum or minimum point. So if we look at this first graph here, what I notice is that I have a graph that's going up, 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 up. It reaches this vertex point here, and then it goes back down. And if I look at this vertex point here, it looks like it's on the top of a mountain. It looks like it's on top of the world. It's right on top. It's the highest point. If your vertex point is your highest point, then it is going to be called a maximum point. So here, our vertex point on this particular graph doubles as a maximum point. This is then different than what you see on the second graph, because we'll notice this one is going down into a valley, down into a valley, down into a valley. It gets to this point down here, it's like the absolute bottom. You've reached the bottom of the barrel, and then you're going back up. This point right here, if it looks like it's the lowest possible point, that's because it is, and that vertex point is called a minimum point. Now if we look at the next additional graphs here, what we're going to see is we're going to start to see a pattern. So here, we're going up, 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 up. We reach a point where we're on top of the world, and then we're going back down. Because we are on the very, very top of that hill, our vertex is a maximum point. And then finally, in this last example here, you can see we're going down, 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 down into the valley. We reach the absolute lowest point, and then we shoot back up again. So this is our low point here, and as a result, our vertex here is a minimum point. Now, while we can clearly see from a graph if we have a minimum or a maximum point, we can actually also tell if we're going to have a minimum point for our vertex or a maximum point for our vertex by simply looking at the equation. So what we're going to do here for each of these four examples is we're going to decide if the graph is going to open up or down. And then using that knowledge, we're going to decide, is our vertex going to be a min or a max point. So here I can see in this first example that I have an a value that is equal to a positive 1. Because a is equal to a positive 1, I know that my graph is going to be a normal U shape, which means that my graph is going to open up. Now what this also tells me is if I look carefully here, what I notice is that my graph is going down, down, down. It reaches this lowest point right here, and then it goes back up. So because of that, if a graph opens upwards, its vertex point is going to be a minimum point. So now if I look at example 2, here I notice that my a value is equal to a negative 2, which tells me that I have a graph that's an upside down U. So I know that this particular graph is going to open down. And what I notice here is that my vertex point at the very top looks like it's on top of a mountain. It's on top of a hill. As a result, that vertex point is a maximum point for that particular graph. If I then look at my third example, I have an a value equal to a negative 3. Again, that a value being negative flips it over to be an upside down U. So I can see that my graph opens down, and I can also see that my vertex point is on top of a hill, so it is a maximum point. And then finally, this last example here, a is equal to a positive 2, which means we have a normal U shape that is opening up. And as a result, our vertex point is the lowest point there, also known as a minimum point.